To deal with a kind of intelligence in video games, there are many concepts. These concepts are used in games we all know and help to make an enemy or an ally much more alive. Among these concepts, we can mention decision trees, state machines, machine learning, etc. Today, I'm not going to present the different concepts at all because I'm bad as f*** at game development. Instead, I'm going to talk about the different thoughts I had when designing my enemies. First, let's make a little reminder about my game. You are the survivor of a post-apocalyptic world in which humanity has turned into undead. Your objective is to go to point B to retrieve a precious object that must be brought back to point A. Your enemies are very powerful, so you must use the strategy and the tools at your disposal to accomplish your mission. Every noise you make increases the difficulty of the game. Please take 5 seconds to wishlist the game. It would help me a lot. Thanks. For now, the only enemies are undead. I made this choice because the intelligence of a zombie is generally limited, which makes the creation of the AI much more easier and speeds up the development a little bit. The zombie is able to move, its speed will always be the same. A field of view system has been implemented based on the excellent video made by Sebastian Legge. It's possible to customize the height, width and depth. Other classic features has been added such as life system, ragdoll or nerf, which we will see in the future episode. In my gameplay I've chosen to have several phases for a zombie. An observation phase, it stays still and rotates randomly. A patrol phase, it follows a defined path. A phase of movement towards a position, it moves towards a precise position when it hears the sounds of footsteps, for example. A phase of movement towards the player, an attack phase, and a death phase. We can define these phases as actions, represented here by a rectangle. To go from one action to another, we need one or more conditions. So, the switch to the condition and then to the new action is called a transition, and we can call the whole thing as a state. With these elements, we have the basis of our intelligence system. Okay, so let's put our theory into practice. Here we have our beautiful enemy. This one moves on a defined pattern. This is the patrol state. Let's imagine that the sound of footsteps is emitted at 20 meters away. The distance is too important, so our condition is not valid, though the action does not change. A shot is fired. It is noisy, so the enemy hears it. The constraint is thus validated. The enemy then changes the action and moves towards the position. Each action has several conditions that lead to new actions. All these actions and all these conditions form something that we could call brain for our enemies. I hope you have understood the principle. I will now quickly show you what my actions and conditions look like. Of course, we find all the actions mentioned before. The technique is based on states, so action plus conditions. This concept is called Finite State Machine. A finite state machine is an abstract machine that can be in exactly one or finite number of states at any given time. It can change from one state to another in response to some inputs. The change from one state to another is called a transition. A finite state machine is relatively powerful and can do many things. Nevertheless, there are some problems. The main flaw of a finite state machine is that it's predictable. If this condition occurs when I am in these actions, then I know exactly what the next action will be. I think that can make the enemy gameplay less fun, but my game is intended to be a strategy game, so I think that predictable gameplay might make it interesting to play. For the moment, I'll stay on it and I'll see in the future to modify it if necessary. I could, for example, increase the complexity of an enemy by adding new actions. I hope you learned something and especially that you enjoyed the video. Remember to put a thumbs up if you did and subscribe if you're not. Thanks.